So we've got here a bunch of different equations. Force is equal to mass times acceleration. Pressure is equal to force over area. Voltage is equal to energy over charge. Velocity is equal to displacement over time. Current is equal to charge over time. Resistance is equal to voltage divided by current. And work is equal to force times displacement. We've colored them in yellow, the ones that are measured in base SI units. These are the 5 base SI units. And the ones in pink are not measured in base SI units. So now what I'm saying is that it's possible to turn any other unit and that is not a base SI unit into a combination of base SI units. So I'm going to do a couple of examples here, and then we'll look at how we can do more after that. First of all, I think some of these are a bit squashed up. Whoops. Oh, great. Some of these are a bit squashed up, so I'm just going to move them a little bit over. Oh, I can't because it's not taken. Oh, it's okay. Never mind. Hopefully we can see that that's one equation, that's another equation, and so on. Maybe if I just move these. Oh, no. Right, so I'm just going to move these ones down a little bit. The trouble is it leaves the comments behind, which is really annoying. Okay, fine. Right, now I've got to move that now. You can't even see the V. Okay, so we've got, let's look at this one here for a start. Work, which basically is a measure of how much energy is used on to do something useful. It's the standard example is you push a block, a meter. Well, that would be the definition of 1 joule. Well, okay, so if you push a block like this, and I'm moving it that direction, and let's say the force, I've pushed it with a force of 3 newtons, and I've moved it 2 meters, then the work I've done is equal to the force times the displacement, which would be equal to 3 times 2, which is 6 newtons. Now, so basically, if that was 1 newton and 1 meter, then it'd be 1 times 1. So, we can say, therefore, that 1 joule is equal to 1 newton times 1 meter. Because work is measured in joules, and if I pushed one block a 1 meter and with a force of 1 newton, then it would be equal to 1 newton times 1 meter. So we can rewrite that as just 1 newton meter. Now we don't do that, generally speaking. That is not the official unit for energy. However, you could write that as that. That would be a combination of base SI units. So these, we can write any unit at all in terms of, oh, sorry, we haven't quite done it yet. This is a start, though. So if we take one of these rectangles here, we can say, but now that is a base SI unit, but we've still got this one here is not a base SI unit. So, but we're halfway there. So what about now something that's measured in newtons? Well, that'll be force. So force is measured in newtons. So let's have a look at that. Well, force is measured. So we know that force is equal to ma, and that's, so in other words, so we can say therefore 1 newton is equal to 1 kilogram multiplied by 1. Now, the unit of acceleration I've written as meters per second per second. So we'll just write that for now, meters per second per second. You can rewrite that as meters per second squared, and that came up in GCSE. Now, when we do A level, what we want to do is get rid of this slash. We don't like slashes in A level for some reason. So what we're going to do instead, we're going to rub out that, and we're going to instead write meters second to the -2. It means the same thing, but that's what we're going to write from now on. So what we would do then is we would say that 1 Newton is equal to 1 kilogram times by 1 meter per second to 1 meter second to the minus 2, which is then you just rewrite that as 1, or you don't even really need to write the 1. You just write kilogram meters second to the minus 2. Now we've got what Newton is, kilograms meter second to the minus 2, which means we can write this one up here as all of that multiplied by the meter, which then we have 2 meters, so kilograms, meters, meters times meters, meters squared, second to the minus 2. So that is an example of turning joules into base SI units. Kilogram is a base SI unit, meters is base SI unit, and second is a base SI unit. Okay, so what we need to try to do is see if we can work out the rest of them in terms of base SI units. Now, actually, I shouldn't have. Well, okay, so this we coloured as pink originally, but it's measured in meters per second. So what I think we probably should have done, to be fair, is said if it's a combination of base SI units, we can also colour it in yellow. So we can do that. But we're going to now try to turn other things into a combination of base SI units. Okay?